Okay, it's 6:30. Let me know if you can't hear me on Zoom or if you can't hear me in the room, and I'll try to speak up. So, good evening. My name is Kate Windsor, and welcome to Northeast Metro Climate Action's May event. Here comes the sun and wind and batteries and etc. So, just so you know, we're recording this presentation and we'll make it available on our website and our Facebook page and our YouTube channel. So before we begin, I'd like to make a land acknowledgement. We're meeting on the traditional homelands of the Anishinaabe people who continue to live in the area and exercise treaty rights on this land and surrounding waters. We humbly work to honor this living history. So if you don't know, Northeast Metro Climate Action, and we kind of call ourselves NEMCA, we're a local group of neighbors, friends, and like-minded community members that believe in a healthier and cleaner and sustainable future. And we're all volunteers. Our mission is to broaden the awareness of the climate crisis and and to broaden our awareness and the reality implications of the changing climate to our neighbors, community, and elected officials so we can preserve a livable earth for ourselves and the next generation. So we carry out our mission by hosting monthly events like this one and are actively involved in educating our elected officials, and that's local and state politicians. This is our last event until September. In the summer, we like to participate in parades for climate-friendly candidates and tabling at various community events. So if you need more information about NEMCA, you can visit our website and our Facebook page, both under northeastmetroclimateaction.org. And we post a lot of events hosted by other like-minded groups as well. So tonight we have several co-hosts. They include Resilient Roseville, Northwest Metro Climate Action, Vote Climate, Vadnais Heights Green Team, Sustainable Stillwater, Minnesota, East Metro Eco-Faith Collaborative, Indivisible North Metro Environment Team, St. Croix Valley Indivisible Climate Justice Team. So for those of you online, please mute your microphones during the presentation, and you can put your questions in the chat or save them to the end when you can raise your hand and ask to be unmuted to ask your question in person. So tonight's speaker is our very own Dr. Steve Jorissen. He's an adjunct professor in chemistry at the University of St. Thomas and teaches the science of climate change and clean energy in his courses. Dr. Jorissen is a co-leader of our group, NEMCA. He serves on the Vadnais Heights Planning Commission and Green Team and serves on the board of Resilient Cities and Communities. I know you've given this presentation many times, but things are changing so fast. I hear you've had to update some of the slides to keep up with technology. So welcome, Steve.
Yeah. Okay. All right, thank you. So we're going to talk about Here Comes the Sun, the transition to a clean energy economy. It's happening already, and we're going to talk about how well that's going in some areas, how fast it's happening, and then I've got my, what we're going to talk about here. Let's see, page down. There we go. We're going to talk about where we are on our journey. We're going to focus on electricity generation. That's kind of the keystone for this clean energy economy, with a real focus on wind and solar and grid scale storage, which is going to be a big help with getting us through those times. And then some new developments and opportunities. All right, so climate advocates around the world use these 4 points to help get us all centered on where we are on our climate journey. The climate crisis is happening already. You have to be pretty much blind to the world around you to not realize that our climate is warming rapidly. It's because of us. We know that. My next slide will show you carbon dioxide content that's gone up because of us. We have solutions. That's what we're going to talk about tonight. And it's not too late. We're already in the middle of it. Every 10th of a degree we can keep it from warming was going to be a benefit.
COVID.
Isn't that something?
Yeah.
Yeah.
The graph on here shows the global average surface temperature. This is a composite of a number of different groups, including NASA Earth Science,
Right.
British Met,
New service. That's the
and
new.
there's my mute. There you go. And you can see it's just obvious to anybody who's looking that our temperature has gone up quite a bit. The last 5 years have been the 5 hottest years in recorded history. This next slide shows what's happened to our carbon dioxide content in the atmosphere over the past 800,000 years. The earlier data is from ice core samples. There's bubbles in those ice core samples. It's like a big file cabinet on the Greenland ice shelf and the Antarctic ice shelf. And they can analyze those bubbles. And they can see that the carbon dioxide content bounced around from about 180 to 280 parts per million for all those years until we reached the Industrial Revolution, and then it just went off the chart. We're this year at current data is taken at Mauna Loa Observatory in Hawaii. They've been taking it since the 1950s. It's called the Keeling curve, and they hit 430 parts per million this year. So we're up about 50% higher than pre-industrial times. Humans are now living in an atmosphere that no humans ever lived in before. The last time the carbon dioxide content was this high was about 6 million years ago when there were palm trees on Antarctica. So big difference. So we have done this. This is primarily from burning fossil fuels. There are other sources, agriculture, and the primary agriculture other than burning fossil fuels. But we're going to focus today on the electricity sector. The world is rapidly converting to carbon-free electricity. Total solar capacity has roughly doubled every 2 years for about the last 2 decades. Now, we started from a very small amount, and now we've got in 2022, we hit 1 terawatt. 2024, we hit 2 terawatts. So there's your double in 2 years. We won't hit 4 terawatts in 2026. It'll be the projections are at about 3.2 terawatts, still a big increase. And we should hit 4 terawatts sometime in 2027. Much of this is being installed in China. China is installing more solar than the rest of the world combined at this point. And they're making about 80% of all the solar panels that are being used around the world. So that's where it's happening. 90% of new electricity generation globally in the last 5 or 6 years has been wind and solar. So all new electricity generation has been wind and solar for the most part. Coal, natural gas, nuclear, everything else has been pretty much flat. As our needs have grown, it's all been supplied by new infrastructure of wind and solar. So the idea is first clean up the grid, meaning take all the coal and natural gas electricity generation off the grid, and then electrify everything, right? This electrify everything is really a catchphrase for a lot of groups that are trying to get people to think more about, your cooking, your heating, your lawnmower. All those things are easily done with electricity and batteries today. Heating options today are really good for electricity. Industry is going to be a little bit harder lift, especially steel and cement production have to reach temperatures that are hard to reach with just electric heat, but we're getting there. So here's what electricity generation has done globally in the last 10 years. In the 2015 chart on the left, you see that the little green sliver there, that's or actually the little orange sliver is solar. 1% of our global output was solar. 3.5%, the green right next to it, was wind. And just look at 2025, solar reached 8.8% of global output. Wind reached 8.5% of global output. So that's what's expanded. Everything else has pretty much stayed the same or shrunk. Coal is going down. Globally, was at 30, almost 39%, down to 33% of our total. Gas is about the same. That's the big gray one in the bottom. So what the big takeaway from this slide is wind and solar have expanded a lot. Solar primarily. Solar will be the wave of the future. That's what's really growing the fastest. Because it is the cheapest. I'd like to say that it's happening because all these people are concerned about the environment and carbon dioxide emissions, but it's really because it's the cheapest is why it's growing so fast. So that last one was global. This is US in a little different look. I put this one up there because it shows that the combination of renewables, which is wind, water, solar, so wind, hydroelectric dams, and solar, outdid gas for the first time ever in March of this year. So you can see right at the end, it says it has renewables over gas. So the light blue line is gas used on the US grid for the last 10 years. It goes back to 2016. And you can see that kind of goes up a little bit, and now it's coming back down again. The pink one that was at the bottom here on the left, that's the renewables. That's got a steady rate increase up. And that's all, it's not hydro, it's just wind and solar is causing the increase. Hydro's in there, but it hasn't changed that much. Coal, you see the dark blue line on the very far left, which is the highest back in 2016, is by far the lowest in 2026. So that has dropped a lot in the US. And it's interesting, you notice the sawtooth pattern. So in the US, we use a lot more electricity in the winter and the summer to heat and cool. And in the spring and fall, our total electricity consumption goes way down. So where you see my cursor? Yeah. Where the renewables is peaking, it's not like we got a whole bunch more renewables. It's just the total pie shrunk a lot. And utilities will shut off the gas and coal because they're expensive and instead use the available wind and solar. So that's why the wind and solar are spiking in the spring and fall, is because your denominator shrunk for you math people. And the numerator went up a little bit, but it's the ratio went really high. And you can see, you can see that renewables spike where gas and coal, or where gas goes down, coal is also down during that time. So utilities can see if we can go with just wind and solar, that's what we're going to go with because that's cheap, right? And the table on the right here shows, it goes back a little farther. I got 2010 on here in the table. You can see solar went from almost nothing, 0.04% back in 2010 to 11.6% of our total in 2026, higher than global. So we're ahead of the curve a little bit in the US versus global. Wind went from 3.4% up to 14.6%. So we have more wind than solar here, whereas globally, solar was a little bit more than wind, but solar will overtake wind here in the US within a few years because it's growing so fast. Coal, you can see, went from 48% of our energy mix down to 11.5. So we're shutting down coal plants. We were shutting down coal plants up until this year. Yeah, that's one. I was just reading about how utilities are being forced to spend billions in taxpayer money, ratepayer money to keep their coal plants open because there's the energy emergency that has been called by our federal government to keep coal plants open, which is just about the dumbest thing I've ever heard of. So that's what we've got going on right now. But there's no stopping wind and solar.
You're speaking to the choir.
Yeah, I know. I know. And as I mentioned, the reason is because it's so cheap. You can see this is from a group called Lazard. The reference is being blocked here by the cameras. But Lazard is an investment banking firm that does like a couple times a year, they'll do what they call the levelized cost of energy, which they take all the subsidies and incentives out of and they take the life cycle cost of the energy being supplied. And you can see that, solar PV, this is a national average, is 4.4 cents a kilowatt hour. It's quite a bit cheaper than that in some areas like the Arizona or Nevada desert, where you got really good solar resources and land is really cheap. There you're under 3 cents a kilowatt hour in some of those areas. But at national average is about 4.4 cents. Onshore wind is 3.3 cents. And in solar PV is down well over 90% since 2010. That price was like 60 cents a kilowatt hour in 2010. Now it's 4.4 cents. And onshore wind is down 60% in those 15 years. Offshore wind is still a little bit more expensive. And again, our federal government killed 3 offshore wind projects, spending $2 billion of taxpayer money to pay the companies that were already starting to build them to stop the construction of those, which would be providing very cheap energy to our East Coast where they need it. But nope, we're going to shut that down. Hydropower is in that mix, but you can look at the fossil fuels, way more expensive. And this is, on the full life cycle basis, coal-fired power plants are 11.2 cents. Natural gas is 8.9 cents. Nuclear is not on here, but that's the most expensive. Nuclear is more expensive than any of these. And, yeah, so that's why it's happening so fast, is because it's cheap. Now, you may have heard that and you've probably seen in your bills, electricity rates are going up. They're going up nationwide on average faster than the rate of inflation. But not everywhere. You see the red states here are where the electricity rates have gone up the most. And this is just up through 2024. So this doesn't even include the rise in natural gas prices that started during the Iran war. And, and a lot of the data center issues. A lot of the increase in electricity prices is because of much increased demand from data centers. That's what's really driving an increase in demand. We were flat in the electricity use from about 2003 to 2023. Our electricity use was flat. And all that time we were adding, cell phones and iPads and TVs, but because of efficiency of LED light bulbs and Energy Star appliances, our total use was flat for all those years. Now in the last 3 years, we're spiking because of data centers, AI and crypto primarily. And that's driving those utilities to go fire up those gas and coal plants again, which is more expensive. And that's driving the electricity costs up, especially in the Northeast. That's where you see, New York and Maine are going up. The Southeast is primarily natural gas. And I think if we were to do this again after the natural gas prices came up after the Iran war, they would be all red as well. Where the big blue in the middle is where we have wind power. It's Kansas, Nebraska, North Dakota. Wind energy does not go through the Strait of Hormuz, and and it's kept prices have gone up a lot less than the rate of inflation. Minnesota's electricity rate has gone up just a little less than the rate of inflation. You probably notice in California is a little darker than the other states. Now, and we're going to talk about California quite a bit here because it's an interesting situation. The price of electricity in California is very high for very different reasons. The top two reasons are wildfires. The utilities are paying huge fines for causing wildfires that wiped out entire cities in California. And those fines are being passed on to the ratepayers. The second reason, also wildfire related, in those lawsuits, they're being forced to upgrade their grid system so that they don't start more wildfires. And that upgrading the grid is very expensive. Those expenses are being put on to the ratepayers. And the third reason, it's kind of a catch-22 here, the rates are so high that over 2 million households in California now have solar on their roofs. And the utilities customer base is shrinking because they're not selling as much electricity, but they still have to pay all these bills. So the people who are still on utilities and don't have solar panels are paying a lot more because the customer base is shrinking. So that's why California's is so high right now. It actually, since 2024, their rates haven't gone up as much as some of the other rates, but it was already at a very, very high rate. My daughter lives in California. They're paying over 50 cents a kilowatt hour in some part, sometimes of the day, where we're paying about 15 cents a kilowatt hour here. So yeah, but we're going to talk about California here in a minute. Okay, so wind and solar are great, right? Oh, but they're on, you always hear them say, the wind doesn't blow all the time, the sun doesn't shine all the time, right? And the answer to that is grid scale storage. So this intermittency is what they call that, when you can't get the power anytime you want it, as opposed to firm resources, meaning like hydropower is a firm resource. You can get it, it's dispatchable. You can get it anytime you want. In order to get wind and solar to be firm power, we need to be able to store it when we're making more than we can use, and then dispatch it, deploy it when we need it. Now, what you see in the picture here are very likely lithium iron phosphate batteries, or boxcar size batteries. We have a couple of these installations in Minnesota. Connexus installed a couple of them, and Excel is now putting more of them in there. Lithium iron phosphate is used for these because rather than lithium ion, it's a little cheaper, it's heavier with the iron in there. So it's not great for cars where you want really lightweight, but it doesn't have cobalt and it doesn't have nickel in it, and they're cheaper. And they're actually a little bit better on a return trip efficiency. They're up around 95, 96% efficiency on getting the energy back out versus about 91, 92% on lithium ion. But since they're just sitting in a field, it doesn't matter that they're heavy. And this has been primarily what we've been installing for grid scale storage around the country. And I'm going to talk about a different technology, iron air, here in a minute, but for battery storage. But there is another way to store energy, and has been around a long time. It's called pumped hydro. And we built a lot of these back when by coal plants because, well, let me back up just a little bit. The demand curve during the course of a day, it isn't steady. Pretty much everywhere in the United States, you use very little electricity overnight. Then it ramps up in the morning when people get up out of bed. And then it kind of goes down a little bit in the noon hours. And then the big peak is between 5 and 8 p.m. People get home from work, turn on their ovens, their TV, turn up their air conditioning. And it has the shape like this. They call it the duck curve because it looks like a duck. And so if you're building a coal plant that has to meet the high demand at between 5 and 8, you're going to have to build a very big plant, unless you do something like pumped hydro next to it, where and with pumped hydro, what you don't have to be on a river. You're going to have one reservoir up and one reservoir down, and then let the water flow from the upper reservoir to the bottom reservoir like a hydroelectric dam, turns the turbines, gets electricity. And then when you're making more electricity than you need, you pump the water back up the hill, refill the upper reservoir. So if you had a coal plant, you'd keep it running steady all the time, which is great for a factory. If anybody who works in a factory knows, you'd rather have it steady all the time than ramp it up, shut it down, ramp it up, shut it down. They hate that. So they run it steady, pump the water up overnight, and then they can build a smaller one because at the peak hours, they let the water run downhill, supplements the coal-fired power plant, and they get the the electricity they need. Now, we haven't built one of those since 1995. There's a company called Rye that's planning new pumped hydro in Washington, Kentucky, and Oregon. These are going to be big operations, and they're also doing this major scale in China, Australia, and some other places where, especially, they have lots of wind and solar, because this really helps with wind and solar as well. So this is an interesting idea, lower tech, right? It's hydroelectric's been around forever. It lasts a lot longer than batteries too, like over 100 years. Something like Hoover Dam's been around for probably that long. So let's go back to batteries here for a minute. Oh no, we're going to talk about batteries, but California electricity mix. Now in California, I mentioned that 2 million homes have solar power. Of those, over 200,000 of them have home battery systems. So they have batteries in their homes like the Tesla Powerwall or other batteries like that. And the California utilities have also been putting in a lot of batteries, mostly the lithium iron phosphate. And in just the last 3 years, they've been able to meet their peak demand between 5 and 8 p.m. primarily by deploying battery power that was charged up during the middle of the day when solar power was really high and generating way more electricity than they need. So you look, okay, we're going to take a deep dive on these charts here a little bit. In 2023, this is from midnight to midnight. Okay, so this is the course of a day. This is a 24-hour day. Here's your morning, overnight, where this is the demand is really low. And then it has the morning peak. Then it comes down a little bit. And here's your peak between 5 and 8 p.m. And so in 2023, what you can see, the yellow is solar. The red is what they call imported. So this is done by CAISO, the California Interconnected Systems Operator. And this is real-time data. I clicked on their website and pulled this off. And this is 1 day in May, 3 years ago versus 2 days ago, okay, in 2026. And the red is imported, and I looked that up. It's mostly hydroelectric from the Northwest, Pacific Northwest, and wind and solar from Arizona and Nevada. But the blue, the light blue here, that's natural gas, okay? So that was their natural gas. And typically what most places do in that the peak hour, they fire up what they call the gas peaker plants. And they need those to meet that demand in those times. Now the purple in this, very little purple in the 2023 one, that's batteries, okay? And then the green is wind. Now, I did notice that the day I picked here, the wind was really low. So that thin green line, I looked on during the course of that week 3 years ago, this was like the lowest wind day that they had. So usually the wind is a little bit more than that. And because you can see in 2026, just 2 days ago, the green is huge, right? They did add some more wind, but not that much more wind. We just had a really calm day back there, just serendipity there. But what you notice here, the big takeaway is, number one, we don't have the trough in the middle of the day here in 2026 because all that extra electricity that was being generated by solar was getting put into the batteries. Okay, so there's more demand because they're storing it. And then the big purple over here on the side, that's the batteries deploying that extra electricity during that peak time. And notice the big blue here was natural gas. It's almost gone here, almost gone. Now, in May, we talked about how you use less electricity overall in the spring months. This is a kind of a maximum of decreasing the gas. Year to date, the last 145 days, California has reduced their consumption of natural gas for electricity generation by 61%. The world's fourth largest economy has reduced their natural gas use for electricity by 61% in 3 years. That's what can happen. Okay, that's how fast this can happen. And that can happen everywhere. And with the right incentives, the right motivation, a government that isn't trying to squash that, those are numbers that we could take anywhere. This isn't Davenport, Iowa we're showing here. This is, California, fourth largest economy. So that's a very important thing to keep in mind. So we can already do it with the technology we have. We can already do it. China's doing it. Pakistan is another country. They've increased their solar from like 1% to about 50% of their electricity needs in the last 5 years. There's a couple of Puerto Rico with all their electricity issues that they've had since Hurricane Maria. They've been really installing a lot of solar. So they get their own solar. Don't have to worry about the grid. So a lot of that's happening already. Now we're going to talk about how are we doing here. Oh, pretty good. Some new technology, really exciting stuff. I'll get to each of these. And they're all very important. Iron air batteries are not future technology. It's new, it's not future. It's happening now. We're installing Form Energy, converted a former steel plant in Weirton, West Virginia. They're making these iron air batteries, 1/10 the cost of lithium ion batteries. Batteries are getting so cheap now, and these iron air is just iron and water are the two main ingredients there for this thing. There's no lithium, there's no cobalt, there's no nickel, there's no neodymium. And it's very, available, cheap, and it actually has longer duration storage than lithium ion. Has a little bit lower return trip efficiency. It's down around 70% instead of the 90% that lithium ion is. But at 1/10 the cost, it's really cheap. So first commercial installations are going in this summer, right here in Cambridge, Minnesota, by Great River Energy. Signed agreements with Excel for Becker, Minnesota, also Colorado. Interesting one is Google is building a hyperscale data center, which I'm not a big fan of, but they're building one in Pine Island, Minnesota, down by Rochester. It's going to be powered entirely by iron air batteries from Form Energy with new wind and solar. So they're going to be off the grid. They're not going to be drawing on grid that the other consumers are going to be drawing. They're going to be off the grid, and they're going to power the whole thing with iron air batteries. Now, to think about, well, I'll talk more about how big that iron air battery thing can be here in a minute. The next technology I want to talk about is called perovskite. And, we've been using crystalline silicon as our sole solar panel material for all these years. Crystalline silicon absorbs, you have the whole spectrum of light that's coming from the sun. Crystalline silicon only absorbs 23% of that, of those wavelengths, and in a fairly narrow range. Perovskite does the same thing that crystalline silicon does, but in a different wavelength range. So with these tandem solar cells, we can put the perovskite right over the crystalline silicon. The perovskite will absorb its wavelengths and convert that into electricity. Let the other wavelengths go through, hits the silicon, that'll convert the rest of it into electricity, and we'll get, in the lab, they're getting about 35% efficiency. It's an increase in efficiency of about 50% over standard solar panels, which is amazingly good. Think about, putting solar panels on your roof, you get 50% more output. That's pretty huge. Or how much land you need to get a big solar farm, you can use 50% less. that's a really great thing. These are a little bit more futuristic. There's some hurdles. The perovskite is not as durable in wet conditions as the silicon is. So they've got some technology things to overcome there. But it's coming. They've been working, I've been reading about perovskite for about 6 or 7 years now. They've been making a lot of advancements. They'll get there. So that's pretty exciting stuff. Solid state batteries. We've been hearing about solid state batteries for a long time. Toyota has been saying we're going to have a car that gets 1,000 miles on a charge and it'll charge in 10 minutes. And the battery will be half the size of the one that's in a Tesla today. Solid state batteries are kind of like nuclear fusion, 10 years away and always will be kind of a thing. At least that's how it's been. But they have been making breakthroughs on it. The promise is there. You get rid of that liquid electrolyte. I mean, it really reduces the size of that battery and the weight of the battery by a lot. Gives it a much higher, what they call energy density. I mean, if we're looking at trying to power airplanes, right, with batteries right now, with liquid electrolyte batteries, it just, they can do a short haul. You can go a couple 100 miles in a small airplane on batteries. You're not going to get across the Atlantic with the batteries we have today. Something like this, maybe, who knows? Right now, they're really expensive. They have really poor low temperature performance, and they are suspect of mechanical failures. So they've got a ways to go on that. I would expect to see perovskite silicone solar panels well before solid state batteries come out commercially. Toyota promised them in like 2023, 2024, and then they couldn't deliver on that. But exciting stuff. Now, geothermal is interesting. There's really 2 different ways of thinking about geothermal. And I don't know if you've met, I'm going to call you out here, Jim. Jim DeMay is running for State House in 36A. And Jim has been on the Mounds View School board for a number of years. And Jim helped get geothermal into 3 schools in the Mounds View School District. And that geothermal, you dig about 15 or 30 feet deep, lay the pipes down, and then you run either air or water through there into a heat pump, and it makes the heat pump really, really efficient. And so these schools in Mounds View School District are going to have really low cost heating and cooling for the next 30 years because of the work that Jim DeMay did there. And the other type of geothermal is where you dig way down and where the rock is so hot, molten maybe, very hot, you pump water down and steam comes back up, right? And the steam can then drive a turbine to generate electricity. That's the type, like Iceland has their molten rock very close to the surface. They don't have to dig down very far. Almost all of Iceland's electricity is geothermal generated. And it's, basically free. They just dig down, they drill down, put the water down there, comes up steam, turns a turbine, and you get your electricity. Not everywhere has the molten rock that close to the surface. New drilling techniques, ironically, developed during fracking development for fracking for natural gas, have allowed this enhanced geothermal to maybe completely replace natural gas itself. So that would be a nice turn of events. But yeah, so there's a company called Fervo Energy, and they're doing a scalable pilot in, I think, northern Utah right now. Right now it's pretty expensive, probably a little bit more expensive than nuclear. And this would be firm power, of course. That rock is hot all the time. You can keep pumping water down there. It's never going to cool off. And you can get the steam to power those turbines 24/7, 365. So firm dispatchable power is the idea here to supplement the wind and solar and batteries. This, again, they're saying that this can be done anywhere with the new drilling techniques. It's just a little bit more expensive. All right. And And then there's the grid. Okay, the grid is old, and expanding the grid is really, really hard and expensive. People who, if utilities are trying to put new high tension power lines, high voltage power lines through a new area, there's all types of lawsuits and backlash and get permits, and it's really hard. One of the things that they're working on is trying to get much more efficiency out of the existing grid. The grid gets very congested during that 5 to 8 period during the peak hours, but it's not used that much during the downtime. And they say that the grid is really at about 50% utilization, even though we're saying we need new, poles and wires to get, but it's only congested between 5 and 8 p.m. So one of the ideas is take iron air batteries, these really cheap batteries, place them around, and I'll back up just a second. The real congestion is on what they call the transmission, the long distance, the high voltage power lines from the power plants or the wind farms, the solar farms to the population centers. That longer distance is where it gets really congested. Then the distribution is a little bit better, in better shape. Once it hits a substation near the population centers, it gets distributed and attenuated into the right voltage and so forth. But it's that transmission that's the logjam right now. If you put iron air batteries around cities and then transmit that electricity and charge up those batteries overnight where the congestion is low, and then deploy that electricity at the peak hours, you don't have to congest. You put extra onto the wires during the transmission during those peak hours. So, and again, I'll go back to that Pine Island Google hyperscale data center. That thing is going to use more electricity than the entire city of St. Paul. If they can power that with iron air batteries, they can power entire cities with iron air batteries, and they're cheap and they're available. And so iron air is one of those things that when you start reading about it, it just makes so much sense on how it can be used to really offset and help fix a lot of this. Another interesting technology that has been deployed on these is more sensors on the lines themselves that tell the grid operators just exactly how much electricity is going through those lines and how much more they can add. Also, the temperature of those lines is important. If they get more voltage through them, they heat up and then they sag because they expand, and they don't want that to happen. So these sensors can tell how much electricity and the temperature, and can really help optimize how much electricity is going through there. So those types of sensors are really helping optimize the grid that we have, rather than spending the billions and billions of dollars to expand the grid. We're going to need to do that too, but the lesser amount would be better. So that's all my new technology and all of my fancy stuff. What can you do? Where do you come into play here? And I put a picture of this book here. I read this. It just came out last August or September, I think. The author's name is underneath here, Ryan Hagan, if you're interested in that. Very pragmatic look at what an individual can do to help accelerate this clean energy transition. And the first part of the book talks a lot about the stuff that I've been talking about. And then the second half of the book is 10 specific actions, very lined out with a lot of particulars of what you can do. And the first thing they say, number one, and this is throughout the climate advocacy, the number one thing you can do is talk about climate and clean energy. Talk about it with friends and family. We need to change the national discourse in this country. I bet you if you asked 80% of the people in America would think it's more expensive to go to clean energy. I would put my money on that. It's not too surprising. There's been so much misinformation put out there by fossil fuel companies, by these right-wing think tanks, by politicians who are paid to do that by the oil companies and the fossil fuel companies. It's not surprising that so many people think that. We need to change the narrative in this country and It starts local, right? Getting involved, vote, help a campaign. We have great candidates here. I was out door knocking for Jim DeMay yesterday. We've got lots of local candidates, especially local candidates where people don't, I knocked on 31 doors yesterday, and I'm sorry, Jim, not a single person had heard of you.
I believe that.
And that's why I'm out there door knocking, right? And that's because people just aren't very informed. We've got to be talking about these things. We got to talk about climate champions out there. Learning more. I'll back up. Talking about climate change and clean energy, you don't need to be an expert to talk about climate change and clean energy with friends and family. Just tell them you're concerned about it. Tell them how you feel about it. If you have a personal story about climate or clean energy that is positive, that goes a lot farther than spewing scientific facts like I always do. Okay, so that's where a lot of the advocates say, talk from your heart rather than from your head about climate, because talk about how you feel and that you're concerned about it. But learning more about climate and clean energy doesn't hurt either. Or join or donate to a nonprofit. Only 3% of charitable giving goes to environmental nonprofits. 3%, that's it. I was in a graduate level course on nonprofit board governance, 30 people in there. I was the only person in there who was interested in working with an environmental nonprofit. All the rest of them were health and human services or the arts, which are important too, but only 3% for environmental. Come on. All right. So those are things you can do. So in conclusion, shout this from the highest rooftops. Wind and solar are the cheapest forms of electricity generation today. Grid scale storage solves intermittency issues. New technology will make it even better, and we can all take action. All right. I have time for questions. Yes. That's a great question. The question was, will peaking energy prices play in the transition? Our president is doing a lot here in the United States to try to squash renewable energy. He's accelerating it in Europe, China, and every other country, because with oil prices going through the roof, gasoline prices going up everywhere, electric vehicle sales went up like 25% in Europe from month to month after the start of the Iran war. And more wind and solar is going up. It has a very profound effect. I was just looking today that when do different agencies think peak oil will be? Peak oil meaning, when are we going to reach our maximum oil and start coming down? And I mean, up till 2025, we've increased our amount of oil every year, except for during the pandemic. It went down a little bit because everybody stopped driving and flying. But I think we're going to go down this year in 2026. The IEA, the International Energy Agency, expects peak oil to happen in 2030. I think it might have been last year, because I think once Pandora's box is open and you can see how fragile the supply chain of oil can be, it's like, the other big thing about, I'm sorry, but one of the big things about differences between petroleum-based and renewable energy-based is equity. Petroleum-based economies are set up to enrich a few people, a few countries. We have petrostates, we have oil executive billionaires. Distributed energy resources, DERs, our solar and wind, are there for everybody, okay? There's not going to be billionaires coming off of solar panels. It's everybody gets their own sunshine. Everybody can, and it's much more equitable. So as we transition more, and hopefully this, however many bad things are coming out of the Iran war, which is horrible, one good thing that may happen is it may accelerate the transition to clean energy in a lot of different places. That's a great question, by the way. Any other questions? Yeah, Joe.
So, I've been hearing about plug-in solar,
Yes.
and the legislature was considering making it easier.
Yeah.
Do you know if that passed?
I'm pretty sure that the question was plug-in solar. Did it pass in the legislature? I'm pretty sure it did not pass. A couple of states have passed that. They use it a lot in Europe. Basically, the premise there is you get a portable solar panel, and in Europe, they call it balcony solar because the apartment dwellers can just put these solar panels out on their balconies. You just plug them into your wall outlet, and it drives the electricity back into your electricity system. And you can run your appliances off of just plugging a solar panel into the wall. You don't need Excel to come get you a hookup, or you don't have to, get extra switches on your breaker box or anything like that. There's a couple of things that utilities are concerned about. One is you might overload your circuits and cause a fire. If you get too much electricity, I mean, that's a valid concern. The other one is that if there's a power outage and people are using that, the electricity going back onto the grid from these could electrocute a line worker, which is also a concern. So that's why there's not this, it's not like plugging in a toaster and let's just go with it. There's more to it than that. So it's a great question. It's a great technology. We got to figure out how we can use it. Any other questions?
There's one in the chat.
Okay.
Says what countries manufacture
Okay.
the other 20% of the solar panels?
Oh, yes. Okay. So what countries are making the other solar panels? A lot of them are coming out of Vietnam. Actually, when there was huge tariffs on the ones coming from China to the United States, we were getting a lot of ours from Vietnam and other Southeast Asian companies. Through Biden's IRA law, there was incentives for companies in the United States to start making solar panels. Those have all been rescinded. So I don't know if we're going to get any solar panel companies here. There might be a few in the United States, but they're not really significant. Bob, did you have a question?
Well, I was just thinking about the data centers. I didn't hear anything about those, but that's a huge issue now.
Yeah.
They're going to increase the need for electricity greatly. A lot of communities don't want them.
Right. Yeah.
Understand. What would be the result if we simply outlawed them? Like I said, they can't be built.
Right. So the question is, what about data centers and can we outlaw them? Yeah, I know that AOC and Bernie are proposing a ban or a moratorium on data centers. We're looking at, actually, I think a couple of towns in Minnesota have banned them, right?
Moratorium.
A moratorium on them, right? But yeah, and so data centers are huge electricity and water uses, and they really have to get a handle on it. One of the things that the people who are saying, "Oh, it's not that bad," are trying to argue is that if the data centers were to use off-peak electricity to run, these, the electric utilities could get better, could line out their electricity use constantly throughout the day, right? If there's a term there that's like, it's the grid tells you when you can get electricity. Okay, and there's a term there. I was just reading it today. I forgot what it was called, but when you can't get your electricity unless the grid is really flush with electricity, ready to deploy. If the grid is being congested, you can't get electricity during those times. So there's a term for that, whether it's applied to data centers or hot water heaters in your house or charging an electric vehicle. These are all things that don't need electricity at that certain time. You can charge them up or heat up your water anytime. And why not do it when electricity is mostly available, right? Those are things that are flexible in their demand, right? Rather than a TV set, which you need to have electricity on to run it. So, and with a data center, you need to have some big batteries there in order to charge those up during the off-peak time. So
You just mentioned the one at Pine Island.
Yeah,
They're gonna build their own supply, right?
right, yeah.
So that's answering your question.
But we really need to keep I mean, they're building more than they need because that's where the money is. And we'll see how this all plays out. It's a little scary seeing how much is going in it. And watching these, I don't know if you've seen the videos of the commencement speakers getting booed by the college students. Those are pretty funny when they're talking about how great AI is and how it's going to touch they all got booed off the stage. So who knows where we're going with AI. So did you have a question?
And what about poor people that live where they're building it?
Yeah.
They're taking our natural resources and utility, water. This all has to be cooled.
Right.
And
And
how can we see explosions that this?
yeah,
Because they have to literally cool Centerstown and it's jacking up all utility rates to the poor farmers that live there.
yeah,
And they're trying to redirect all the water supply.
right. And there's a lot of issues with those, and that's why we need to make sure that we're governing that well, which we are not at this time. Yes.
So demand for copper.
Yeah.
Any of that, demand going up because I need this.
Sure. Yeah, so I haven't looked into that a lot. But the demand for copper, yes, the demand for copper and, yeah, and so, right, so like in the Twin Cities right now, there's copper thieves because the price of copper has gone up and you're yanking the wires out of street lights, and they're selling it. And that's an issue. Price of copper is an issue. Availability of copper is an issue. We will need more copper. A lot of the lines are, the electricity lines are copper. This doesn't really solve that. We will need more copper. What we need to do is recycle copper at the same rate that Europe recycles copper. If we recycled copper at the same rate that Europe recycles copper, we would have way more than any mining in the boundary waters or anywhere else would give us. We're just too lazy to separate it and get it out. I mean, I've been trying to find, along those lines, I was trying to find, could you go landfill diving to pull all these cooling coils off these refrigerators that are in there? Because that's all copper, air conditioners, refrigerators, that's where a lot of the copper was used. And, but there isn't really anybody doing that. So the more we recycle, the less we would need to mine, and we could do just fine with that. And Jean, did you have a question?
Yeah, is it easy to convert a house to geothermal, a 34-year-old house? Yeah.
The Oilingers did that. They dug into the ground and put the pipes in. Did you do a vertical or a horizontal? Vertical. 5 vertical wells. You have to have a little bit of area there. You dig way down, and then it's expensive. I mean, the system will be, $30,000 or something like that. Yeah. And so it'll be more expensive, but then if you plan to live there another 20 years, it ends up paying for itself, right?
There's a couple of comments.
Okay.
Yeah.
Okay. All right. All right. Yeah, so Google Nest, yeah, so Nest smart thermostats are a really great way to reduce your energy use. We've had one for a number of years and our electricity use has gone down quite a bit. And you can also look on Excel's website. If you're an Excel customer, they will tell you how much electricity you're using compared to your neighbors, which is also very interesting to do if you dig into that Excel thing. Yeah, so Minneapolis is looking at a 6-month moratorium on data centers as well. Okay, so question about copper. We have Eric Lamplin here saying that a lot of the data is for fiber optics. It uses fiber optics instead of copper, but you still need the copper to power it. So that's and that's all the questions and comments. All right, any other questions? Yes.
When are we gonna get our EV charging station infrastructure built in this country?
Well, that's a great question. Well, they've slowed that down quite a bit. Tesla has the most extensive charging network in the country. They've through their CEO's infinite wisdom or lack thereof, they've really cut down on adding new charging stations over the last 3 or 4 years. But they still have the most extensive station. There is money in the Minnesota budget to they have like EV corridors, like most of the interstates is where they're putting the EV charging stations. It's rural areas that don't have them. We took a trip up into northern Michigan last year. They don't have any Tesla power station, Tesla charging stations anywhere in the Upper Peninsula. So they've got work to do up to get all that built out. You know, you think about, I mean, just taking a step back, you think about the complexity of getting a internal combustion car to run. You know, you drill oil out of the Gulf of Mexico, you send it to a refinery, and you make all this energy to convert it to gasoline, and then it has to go. You put it in a truck and send it to 10,000 gas stations around the state of Minnesota, and then you have to drive and go fill it up at a gas station, and it's all smelly and it's expensive. Compared to an electric vehicle, you get home, takes you 10 seconds to plug your car in, and everybody has it. I mean, the difference is not even close. Now, charging on when you're doing long travel, long trips, is when you have to stop at, you know, public charging stations. If you do a lot of long travel, you end up doing that a lot. Other than long trips, I hardly ever use them. And people always ask me, how long does it take to charge your car? I always say it takes about 10 seconds. When I get home, I plug it in, I walk away. It's literally, that's how long it takes me to charge my car. I don't even know how long it takes, because by the time I get back to the car, it's already charged up. And I only have to do it every 3 days or so. It's not like I have to do it every day. So that's a great question too. We need to build out a lot of this. So, and we're getting there. We're working on it. Yes, one more.
Stop paying for the February 2021 weather incident on your exit back, and you'll never read your utility statement, and
Yeah.
we've been paying for it.
The way
For
from
Storm
Texas.
Uri, so February
Oh.
2021, and a flip your
Oh, yeah.
monthly bill over, and it's there every
Yeah.
$5 to $10 every month.
Yes.
Dumbass in Texas.
Yeah. And as a chemistry professor, one of the things I always tell my students is, you know, the first thing that the governor of Texas said during the great Texas freeze out was that the windmills stopped working. Well, they didn't stop working. The postmortem on that was that the gas plants is what really let them down. And they said the gas lines froze. Well, the gas lines didn't freeze. Natural gas is methane. It freezes at about minus 300 degrees Fahrenheit, something like that. It's, for those of you who have taken chemistry or physics, when the temperature drops, the pressure drops. And Texas put all their gas lines above ground. They went cheap. And they put all their gas lines above ground instead of Minnesota, where we all have them buried where it's 50 degrees Fahrenheit year round. So the temperature dropped, the pressure dropped, and they couldn't move the gas through the gas lines anymore. And that's what caused their power outages.
CEO, you're gonna have that.
So I don't know when we'll stop paying for the great Texas freeze out from 2021. All right.
Thank you, Steve.
Thanks.
And the library is open till 8 o'clock, so I'm sure Steve would be happy to converse with you if you have any additional questions.